All right, welcome back, everybody. In this video, we're going to take a look at our first example of a Laplace transform. Okay, and then we're going to apply that to a constant. So what if we want to Laplace transform a constant function? So, use a definition of the Laplace transform to evaluate Laplace of 1. A couple of things here, like this constant 1. Well, that's going to be our function. So, we could consider that our f of t in the definition of Laplace transform. So let's rewrite the definition just to have it handy of the Laplace transform. So, you know, the Laplace of f of t equals the integral from 0 to infinity e to the negative st. Oops, sorry. F of t and d of t. All right, so that's the definition. We're going to use this to find the Laplace transform of 1. So let's try that out. So the Laplace transform of the constant 1. So what that is the integral of 0 to infinity e to the negative st, and f of t is just going to be 1. So like times 1. Okay, so that's f of t. But anything times 1 is just itself, so all we're left with is just the integral of 0 to infinity e to the negative st dt. Okay, so this is just our integral now. Our function is t here that we're integrating with respect to. So you could consider this, like a mental use of situation. And so the integral of this is going to be e to the negative st all over negative s, and we're going from 0 to infinity. Okay, so that's a mental use of situation. If you want to do the work, if you are still having trouble with that mental use of by now, you could do like, u equals negative st, du equals negative s dt, and then divide the negative s over. And so your integral would be, 0 to infinity, e to the u times du over negative s. Um, you integrate, so it's just e to the u over negative s going from 0 to infinity, which is just e to the negative st over negative s, 0 to infinity. So if you want to just double check yourself with this work, feel free to, but mental use of just saves you some time. Okay, this is where we're back to our solution. Okay, and so how do I solve this? So I want a value from 0 to infinity. Um, One thing I could do is maybe bring this down into the denominator to make the exponent positive. That'll help us figure out the when we're solving from infinity to 0. So we'll write like 1 over s e to the negative st, and then we'll bring the negative out in front right there. Still going from 0 to infinity. So let's go ahead and plug in our bounds now. So this is like negative 1 over s e to the negative s times infinity minus negative 1 over s e to the negative s times 0. Okay, so let's see. Let's clean this up a bit. Negative 1 over s e to the negative s times infinity plus 1 over s times 0 is just going to be 0, so it's like s to the e to the 0, so this is just going to be s. We could say like this goes to 1. So this is what we're left with. And so this is where we need to kind of define what S is. So if we see we have negative S to the infinity, or excuse me, I have a typo. Let's kind of backtrack a bit. I still left this as a negative exponent. I think that's why I was stumbling a bit. Um, let's come back here. Yeah, let's erase that negative exponent. I was wondering why the solution looked a little strange, but yeah, so no negative exponent. Sorry about that. But yeah, we want to solve this x uh, essentially going to infinity. So we have to be careful what we choose s to be. So what we need here, we want this to stay in the denominator because if this stays in the denominator, meaning the exponent stays positive, this goes to 0 only if s is positive. Because I'm looking at this s right here. If that s stays positive, this infinity, e to the infinity stays in the denominator. And so it's like 1 over infinity and it goes to 0. So we need that s to be positive. So if s is positive, this whole thing goes to 0. And so I'm left with just 1 over s. So therefore, the Laplace transform is 1 over s for s greater than 0. Okay, so let's kind of take that another step. So if s is positive, then this is like negative 1 over s e to the infinity, which also just goes to infinity. So in case you're having trouble with that breakdown, this will be negative 1 over infinity plus 1 over s. But yeah, this just goes to 0. So just making sure we understand the term going to 0 if s is greater than 0. So that's our answer, 1 over s. Okay. So that's what constants usually go to, 1 over s. All right, but we'll see some more examples. Sorry about the negative mix-up. Hopefully it still made sense. But that's it for this video, and I'll see you in the next one. All right, take care.